Brian should be standing by.
No, don't do that.
Hello?
I'm
Hey, Brian.
Hey.
Brymat.
Hey.
Okay.
Oh.
Now it should be right.
Like now I found it.
Well, I have to have
Is it
you
working?
guys in different Skype channels. That's the thing.
Okay.
Sorry about that. Brian, hey, this is Hal.
Hey, how's it going?
Pretty good. Pretty good. So, thanks for your patience for last time. Sorry about that.
No problem.
Used to be
Happens.
we had like a long string of bad streaming. But we've been really solid for I don't know, a year or whatever. So
I think
that was
pretty much since I went to 8.1. I think that was the last bad time we had.
And I think there was a time when my end was bad as well. I was
That
always
could be.
Cylon. You remember that?
Oh, yeah.
The Cylon days.
Cylon. Is this a Battlestar Galactica reference?
Yes. Sometimes when, for whatever reason, when Skype doesn't get the CPU it needs or the bandwidth it needs or something, you end up with a artifact to the sound, which sometimes we call it bandwidthy, sometimes we call it Cylon, but you sound like a robot.
Okay, I see.
But that's not what we're doing tonight. Tonight we're good to go.
Okay, so we're live now, right?
We're mostly live. We're streaming. You could say that.
Streaming.
We're streaming.
The streaming's working?
Yes, I'm
All right,
doing
so,
That's good.
my other way.
all right, so I'll start.
Okay, well, hold on just a
just-
moment, or just Jonathan, are you happy with the audio thingies?
So far, yeah, I just started recording.
Cool. Let me make a copy of the show notes super quick, and then we will get started. I will guide you along, Brian. Don't worry about it.
Okay, no worries.
And I will. Episode 308, Jonathan.
Yes, 308.
Okay. Share button on the show notes. Okay, that's done, Jonathan. And let me see. Where are you located, Brian? Up in Redmond area?
Well, I'm a bit more north of Redmond, but yeah, my team is based out of the main campus in Redmond.
Gotcha. Cool. Yeah, I was up there just 4 weeks ago, something like that. I
Oh,
was
that's cool.
presenting at a conference there at the Microsoft Conference Center.
Oh, okay, cool. Building 33 there, yeah.
Exactly.
Yeah, that's cool.
Like to
What
be
are
up there
you
and know
presenting
it.
on? Might I ask?
I'm not sure if you've heard of the show Tech Mentor, but Tech Mentor
No,
was
I've not heard of
there
that.
on site. The IT professional show, kind of heavy on deep dives and hands-on labs. I was doing a hands-on lab for basically big data tools for the IT professional. Emphasis was kind of mostly on Splunk, which is my employer.
Okay.
So it was cool. It was cool,
Cool.
and fun.
Very
So,
cool.
what do you think, Jonathan? We good to go?
Yeah, I think so.
Feeling it? Jonathan, are you feeling it?
Yeah, we're good. I'm feeling it.
All right. Awesome. So, we are episode 308. We have a couple. Okay, hold on. Dude in the chat room. Oh, we have 2 dudes in the chat. We have at least 2 dudes in the chat room.
Very cool.
Yeah, we just moved
Normally we'll
nights,
have like
so.
a dozen, but yeah. We've got 15 people in the chat room. I will say hi here. Wait, no, it's not here on this channel. Send it now. Oh, well, 58 people in 8 time zones. That's the wrong button. Hold on a second. What is the there's a special user ID on Slack, which is like everybody in the channel who is like watching right now. If I can figure out what it is. It's not. Oh well, I don't care. I'm over it. Okay. Tonight on the PowerScripting podcast, we are pleased to have with us here for the first time Brian Matthew from Microsoft. Brian, welcome to the show.
Thank you so much. I'm happy to be here.
So I wanted to have you on. There was a topic that I was kind of interested in. You know, Windows is big. Windows has been around forever. And there are pieces of it that occasionally I find that I am surprised to have not heard of or just, you know, kind of slipped under my radar. And this was one of those things where I want to say it was a customer of mine, a day job. They were asking, when is Splunk going to be supported on REFS? And I was like, on what? It's like, that never happens. You know, I should know, you know, all the terms, all the acronyms. You know, I know all those things because this is my space, and I shouldn't be surprised by something like that. So that was what led to initially the reason that we wanted to get you on the show, was to kind of talk to you know, what Microsoft has been doing in storage and in file systems since the old days. You know, where a file you know, the file system was Ntfs, and we have RAID groups, and these are the concepts that have been around for, you know, 15 years, 20 years easily, and nothing new under the sun. So that's kind of the background. Let's before you get into it, why don't you tell us a little bit about yourself?
Yeah, so I'm Brian Matthew. I'm a program manager in the Windows storage team. A little background in our team is that we deliver the storage platform. We build the storage platform across pretty much most of Microsoft's products. So coming up from the Windows Phone, your Raspberry Pi, to your laptop, all the way up to a data center, including even the Xbox. So we build the storage platform for all these different wide range of devices. So we need to consider how our platform would scale from, you know, like I said, from your Windows Phone all the way up to a data center. And our team, going on the file system part, you mentioned you were unfamiliar with REFS. It was a new file system that was introduced as part of Windows 8, Windows 8 / Windows Server 2012. And one of the things I wanted to talk about today is not to talk just about REFS by itself, because we thought about REFS in the context of the larger storage stack. So including, you know, the storage virtualization underneath, like you talked about RAID groups to get your resiliency. And that's the kind of thing, that's kind of how I want to talk about that file system today.
All right. Well, before, how long have you been at Microsoft?
Yeah. So I've been at Microsoft for my 6th-year anniversary just passed a week and a bit ago. So 6
Awesome.
years, and I've been in the storage team for all this time, and working on a wide range of things. I started off in Ntfs land, working on some Ntfs capabilities for Windows 8. We pushed out technology such as offloaded data transfers, also known as copy offload, for SAN arrays and thin provisioning for SAN arrays. And then I moved on to REFS and storage spaces and our storage tiering technologies. And currently I'm working on essentially storage tiering technologies and REFS and spaces moving through 2016. Yep. And I'm originally from Toronto, Ontario. So I moved over to Redmond, Washington, where Microsoft's headquarters are, and that's where our storage team is located. But we actually work with a lot of teams within Microsoft. Like I said, we have to scale across the large range of devices, so we interact with a lot of folks.
So why don't you tell me the scope? I think we'll spend the bulk of our time talking about Windows Server most likely, but I do want to know a little bit about some of the other things that you had mentioned, in particular mobile. What is there that you get involved in, and what does storage mean on the mobile platforms?
Yeah, so on the mobile platform, of course, there's the most basic things such as booting from SD card devices, being able to boot from the internal card or just, like a micro SD card. I just happen to have this in front of me. I'm fidgeting with it. But of course, there's the whole bring up of, the phone does need an actual storage behind it. And there was some work to get Ntfs updated, for instance, to work on the Windows mobile platform. Previously, it was only FAT32. Which is a ubiquitous file system, but there are some limitations of FAT32, such as the inability that it's not a log-based file system. So if your FAT32-based device crashes, you could be in an inconsistent state, and there's some additional handling needed around that. But being a log-based file system, Ntfs has a resiliency for that. That's one of the things that we're doing in Windows Mobile.
Okay, gotcha. Cool.
So why can I only boot my Surface off a FAT32 formatted micro SD card?
So there's some additional interactions there. Like for instance, the UEFI firmware, the standards really only recognizes FAT32 formatted devices, USB devices, for instance.
Oh, that's a limitation.
Yeah, that's the limitation I've observed. Although some other devices do boot off like Ntfs formatted, but they're not as common. FAT32 is pretty much the standard for system firmware booting off like USB devices. But yeah, you'll occasionally see stuff that works with Ntfs though. But I don't believe it's in the standard. But that's not something that I'm fully aware of though.
Okay.
Yeah.
So why don't you talk to us about what Microsoft has been up to, probably starting around the maybe the 2008 R2 time frame, and advances in storage since then. Yeah.
So we started off 2008 R2. It was it's more interesting really to talk about 2012 because that's really when we really introduced our new storage stack. 2008 R2, we did some enhancements that supported SAN arrays, like I mentioned, copy offload and thin provisioning. Copy offload is basically the ability to transparently take a file that's on one device connected to a SAN array to another location on another device connected to that SAN array, and basically instead of having the data bits go through the network, it would go through the SAN array. So the SAN would just do the copy underneath. It would save considerable amount of network bandwidth. The copy typically proceeded faster, and the SAN could do magic to make that happen, or just make that happen instantly. And we've done enhancements like that in 2008 R2. We did some enhancements in Ntfs around check disk. Check disk has been, shall I say, the bane of a lot of IT administrators' times with Windows because, for instance, if I need to go do check disk is basically a consistency checker for Windows, for the file system. And sometimes if, for instance, your machine loses power, on older machines, they might have that screen that comes up and say Windows needs to check your system for consistency. That's check disk. So if you've seen that
You're like,
before, that's
okay, what blocks of my hard drive did I lose? What files no
exactly.
longer
Well,
exist?
it really check this really checks the file system metadata and all the linked data that's associated with that metadata. So, for instance, if my computer unexpectedly loses power, I trip over the power cable or whatnot, and it's not a laptop, does no battery in it. Certain file system operations and associated data operations could be interrupted halfway in between. They could be partially written or whatnot. And check disk goes off and figures out all these different places in the file system metadata that have potentially become corrupted. And it attempts to fix it where possible, relinks missing entries or whatnot, finds orphan files, puts them in a special folder. But the problem with check disk is that it could take quite a long time. And we did some enhancements in 2008 R2 to dramatically reduce the runtime of check disk. Previously, on an enterprise scale volume, check disk could take days. And we reduced that time to minutes or hours through some and more intelligent ways of doing the actual check disk itself. And that was one big enhancement we did in 2008 R2. But the biggest enhancements, really, I have to say, started with 2012, i.e. Windows 8, where we introduced a totally new storage virtualization stack. Did you want me to go into that, or do you have some other questions?
Yeah, please.
Yeah. So a little background on that is some of our most cost-sensitive customers are hosters. They live and die by margins, and they need to basically compete with their competitors, which are also trying to reduce costs as much as possible, but they need to deliver a storage platform which provides resiliency, provides performance, and a bunch of other characteristics their customers needs. But of course, there's always price competition. So they need a storage platform that delivers that dramatically lower cost and complexity. So basically lowering the COGS, the cost of goods sold, to the cost of actually going and purchasing the hardware, and of course to reduce the operational costs as well, right? So a lot of those hosters in the past, they use traditional storage arrays. You have from the big storage vendors, and those worked fine for them. But of course, there's the cost aspect of it. So we approached this problem from a perspective of how can we put this logic that those traditional storage arrays might have into something that the hosters would already buy, and that's the Windows license, right? So by using off-the-shelf commodity hardware, so basically instead of a storage array, which you would have a sheet metal with some built-in intelligence, so you'd have potentially Xeon processors, RAM, storage controllers, all that stuff. With the storage spaces deployment, all you're buying is sheet metal, JBODs, just a bunch of disks, a box with just a bunch of disks in it with storage controller in the back. There's no Xeon processors, nothing like that in there. And those JBODs connect to your Windows file servers, and all the logic of doing the storage resiliency, doing redundancy, doing all that performance calculation happens within that Windows Server node. All right? And we wanted to go further as well and explore how we can actually make these deployments resilient to node failure. So by integrating with Windows Server clustering, we actually have the capability of connecting multiple servers to the same storage. And if one of those servers was to go down, the storage will be transparently failed over to the other server. Right?
Okay, so now we're talking about a clustered file system is the concept. Is this are these called cluster shared volumes? Is that what we're talking about?
Yeah, so that happens with CSV. CSV is another layer in the stack. So you can think of the stack as the bottom level being the physical hardware, right? So the disks inside those enclosures. Those enclosures, they use what's called a shared SAS interface. So I'm sure you guys are familiar with SAS versus SATA. SAS provides the ability. Yeah, exactly. SAS provides the ability for multiple machines to interact with a physical device. SATA does not. SATA is a single machine protocol. So because the disks have the ability to essentially talk to multiple computers all at once, I can, inside this JBOD, I can have multiple servers connected to this machine. You would cluster those servers together, and that would be through Windows Server clustering. You create your storage pool, which is one of the abstractions presented with storage spaces, whereby you take a collection of physical disks, put them into a storage pool, and that provides a means to administer those physical disks and also to isolate them from, say, another storage pool. Within the storage pool, you carve out virtual disks with a variety of different resiliency settings. You can choose no resiliency, which is simple. You can choose mirrored resiliency. You can have 2 or 3 data copies. And you can also choose a parity resiliency, which provides more cost-effective data storage for certain types of workloads like archive. On top of those virtual disks, they just appear to Windows as disks. So if you create a virtual disk in Windows, you open up, disk management, disk part, you'll just see another disk in there. You can format that disk with a file system, Ntfs or Rafs, and then you present that to the cluster, and that shows up, and you add that to CSV. What CSV does, cluster shared volumes does, is that each node in the cluster can see that storage, right? So each node in the cluster can talk to that storage. Because the file system, Ntfs or Rafs, is only mountable on one volume, I can only have that one instance running on one node at a time. CSV provides a means for all those machines to talk to that file system, talk to that volume, talk to that storage at once. Continuing building up the stack.
Multiple physical compute nodes can have access to the same blocks.
Exactly.
Yes? Okay.
Yep. And all the access. Sorry, go on.
I do want to make sure, you just mentioned a new acronym, REFS. We need to define that, and I want to drill down to it at some point as well.
Yeah, sure. So REFS basically stands for the Resilient File System. And it's a new file system that we introduced in Windows 8, Windows Server 2012. I can talk about that a little bit later.
Okay.
But it's just another file system option to Ntfs. There are some application compatibility differences with Ntfs and Rafs. Ntfs builds on 20 years of app compat. Applications have had 20 years of time to tune for Ntfs. So, of course, we expect some application compatibility differences with Rafs. But that's what I just want to highlight up front. So we built up the stack. We started from the physical disk, created a pool, then we provisioned some resilient virtual disks from that, and then we added that to a cluster with CSV so that all the nodes in the cluster can see that storage. And clustering provides all the failover, all that goodness. And
so would you term this as an active sort of cluster?
Yeah. So because so what CSV does is, because I have multiple virtual disks, I would put at least one virtual disk per node, such that all my nodes are essentially active, right? But to really get the active cluster, what I need is scale out file server. And the way that and the reason for this is the way that we look at scale with Windows Server is we have a disaggregated model. The industry calls this aggregated, but realistically it's disaggregated. We like to refer as disaggregated. So those two terms are interchangeable, and that's different from hyperconverged. So I don't want to confuse anybody. I'll just say disaggregated, and I'll explain what it is. Disaggregated means that I can independently scale storage and compute. So these are completely separate hardware resources, and you think of it as different building blocks. So I go off and build my compute cluster, which is my very powerful Hyper-V nodes, lots of RAM, lots of CPU. And these connect over a high-speed network, 10 gig, 40 gig, InfiniBand, you name it, to my storage cluster or my group of storage clusters. And the reason why I would have these scale independently is because typically compute needs grow differently than storage needs. And you'd think they grow together, But for instance, if I have a deployment that has quite a lot more storage needs and less compute needs, then I could have the flexibility to grow that. Or if I am a hoster, for instance, and I need to grow my compute needs for basic clients, I can do that without having to grow my storage needs too much. So it's a really great way for customers, especially hosters, to independently scale what their needs are.
Well, I especially like the ability to add storage without having to consider the space, the physical space available in a given server. It's you don't have them tied together. That means that if you need to add, many terabytes, you can add many terabytes. So there's no physical tie to it there.
Yeah, so there are some considerations when expanding storage, and I can get into that. But it does provide you flexibility to, if I just need another storage unit, for example, I can just add that and away I go. Or if I need some more Hyper-V nodes, I can just add that and away I go. Right? Add that to that cluster and away I go. Mm-hmm. So because they're separate entities, my compute and storage, I need a way for my compute to connect to my storage, and I also want to achieve that active-active, like you said. And what active-active means is that all storage nodes, are constantly pumping bits, right? Because I don't want to waste any resources in my storage nodes. Because those storage nodes, they might have limited resources. I might have cheaped out on the CPUs, for instance, to reduce costs. So I want every node to be active as much as possible. And the way I do this is we have a concept called the scale-out file server. And this differs a little bit from the traditional file server role in a cluster, where only a single node would own that file server role. So I'd only have one node being actively serving SMB shares. With a scale-out file server cluster, it's really what the name suggests. It's scale out, where every node in the cluster acts as a file server node. And for instance, if a compute node were to come down and ask for a resource that was, let's say whack share 1, and share 1, the storage that was underlying share 1, wasn't actually physically connected to let's say node A, but my compute node randomly connected to node A, because that's how DNS round robin happens. That node A would go back and tell that SMB client, hey, you don't actually want to connect to me. You want to go and connect to the guy that owns the storage. So go over to node B over here. My buddy node B, he's the guy that can serve you most efficiently. And the compute node would transparently just reconnect to node B. And this happens all transparently. And this is actually something we did in Server 2012 R2. So to jump between releases here, that's the one big thing that SMB did in that release to significantly improve that access between compute and storage. Right. So we built up
you've been mentioning, I'm sorry if I can interrupt for a moment. You've been mentioning Hyper-V a lot as the use case. Would you say that it is the primary consumer of storage features such as the ones you've been talking about? Are there others, heavy apps, I don't know, like Exchange or something?
Yeah, so we designed spaces especially to reduce costs for hosters. And hosters, they run their life and blood in the hypervisor. Now, of course, there's other workloads that do support storage spaces, but they could potentially have different deployment models. Like, for instance, Exchange has a very specific deployment model that looks a little different. It looks quite a bit different than the model I described. Other workloads like archival can be deployed in the same model I described, but we found today that most workloads just run in VMs. Maybe not, maybe some asterisk around that. But most workloads, being VDI, SQL, for instance, IaaS, all that stuff runs perfectly fine inside a VM, and we find that most customers will run that inside a VM, so they can have that flexibility to move the workloads around, scale out as they need be, and have that seamless failover fault tolerance that's built right in. Right? Does that make sense?
Yeah, it does. Do you want to go into a little detail of those edge cases where it doesn't make sense?
Yeah, so Exchange, for instance, they provide their own redundancy mechanism. Spaces has its own redundancy mechanism, like, for instance, mirroring. So it would take data and throw multiple copies across my spindles and even across JBODs to to bridge those fault domains, provide fault tolerance to not only disk failure, but even entire JBOD unit failures. But Exchange, for instance, they have their own clustering model. They have their own data redundancy model where they manage how they spread data around. So the deployment looks quite a bit different, right?
SQL's like that too, right?
SQL has that capability. Yeah, has that capability. But if you're running, a smaller SQL database or a certain type of SQL database, then you can run it within a VM. It really depends on what your needs are. And I would refer to the SQL documentation. There's lots of different usage modes of SQL. But for Exchange, the way that they deploy is typically I just have physical hardware and I just throw Exchange on top of it. I don't even need to have a RAID card or HBA or I do need an HBA. I don't need a RAID card. I typically don't need storage spaces because Exchange provides all that redundancy for me. So there are some edge cases, but we found that most workloads would run just fine within a Hyper-V, and it provides the most flexibility anyways, right?
So I have a question related to, so we at some point you introduced the term storage spaces, and I want to be clear, is that a set of features or is it a single feature, and when was that particular term introduced?
Yeah, so storage spaces is a driver that we introduced in Windows Server 2012, Windows 8. And it's basically just another driver in the system. You can think of like the LSI SAS2 driver as being a driver to hook up their HBAs. This is a driver that is able to take physical resources in the system, put those resources up bundle those resources into storage pools by throwing out metadata on those disks and then carving out virtual disks and presenting to the system. So that driver has the input of those physical disks and out comes these virtual disks, right? Does that make sense? And of course, there's a whole bunch of management around this as well. So I would consider storage spaces to be the driver technology that's in the system, and also all the different storage management that comes on top of it. Right.
Okay.
Yeah.
Well, at this point, I should ask. Tell us about the PowerShell management options for this feature.
Features. That's very appropriate for this call, right?
Yes, definitely.
So we have a quite extensive PowerShell actually around creating and managing storage pools to managing physical disks, to managing virtual disks. Pretty much any primitive that we have for storage spaces, we have a way to do it through PowerShell. And we have extensive guides on how to do this. And one of the things I actually wanted to bring up in this call is that we have created a set of scripts to help customers go off and not only validate the hardware for a storage-based deployment. Like, for instance, I go buy a JBOD, it's got a bunch of disks in it. How do I know the disks are good? How do I know I don't have a faulty disk? Or how do I know there's not some strange disk in there that I didn't expect, like putting a Sata disk inside a SAS JBOD, right? So we have a set of collateral for leading a customer through a deployment. Before I get into the individual PowerShell, I just want to talk about this workflow that we have.
Okay.
So there's that first script that I mentioned that goes through and validates the hardware's good and does some performance testing. We have a second script that will actually go off and build your deployment for you according to our recommendations. So like I said, we expect most workloads to be based on Hyper-V. So we would build a Hyper-V, a deployment that would be suitable for Hyper-V. And then we go off and validate that, performance test that built deployment. You can find these scripts at aka.ms/spaces automation guide. And you can find all the PS1s in there. A colleague and I built these scripts, so please do give us feedback. They're sort of preview. We've run them on some large-scale systems. We're not having any issues, but again, please have a look. And everything that's in these scripts, we use all our PowerShell primitives to run. And we have a couple utilities like disk speed, for instance, to actually go off and do the performance testing. But all the things that we use to build up deployment is based on all our PowerShell commandlets. Like new storage pool, new virtual disk, new volume. All these different primitives used to manage and provision my storage are all in this script. All right.
Excellent.
And yeah. So please have a look at the script. Please provide us feedback as necessary. And if you guys have any comments, you can just post it right on the Script Center.
All right, great. Yeah, we'll
Yeah.
put a link in the show notes, and we've been dropping links in the chat room as well.
That's very helpful. That's very helpful. Thank you.
So, okay, I'm just kind of skimming over this right now. What is this in addition to? Is it a module? Because I see there's a couple of script names in here, such as provision storage configuration, validate storage hardware.
Yeah. So those, I just built those as simple commandlets, simple just scripts that you would run. So they're not, a module or anything like that. But all our storage commandlets are built off this storage module. And that's built right into Windows. Yeah.
Gotcha.
Was that in 2012 or was that new in 2012 R2? We were talking about that in the chat room. I know it wasn't in 2008 R2 because I've had to script some disk part against 2008 R2. Not my favorite thing to do.
Yes. So the storage module is new in 2012. That is correct.
Okay.
Yeah. So we talked a bit about the 2012 capabilities, building up the stack. Do you guys want me to talk about some of the 2012 R2 capabilities?
I do, but I can't stop thinking about Rafs. So I feel the desire.
I know. We're getting there. I know.
Get to that. Okay. All right. Don't forget, man. Do not let me down.
I won't let you down. Promise.
Okay. I'll let you drive then for a little bit.
So with 2012 R2, what we did is we saw that customers needed not only capacity but also performance. And hard disk drives aren't the most suitable disks to be used as a means of getting the best performance. Because a typical hard disk drive only gets about 200 IOPS. So we see that the industry is moving towards with flash and hybrid model of using flash and disk together. Mm-hmm. And what we did is we took the best capabilities of a hard drive, basically providing capacity, and the best capabilities of flash, basically providing high performance, perhaps at a lower capacity. And we introduced what we called storage tiering in Windows Server 2012 R2. And this is a seamless storage tiering where data is automatically moved between tiers based on their heat. So for instance, hot data would go to the SSD tier, the flash tier, and cold data would automatically go to the disk tier. This happens totally in the background. It works on top of both Rafs and Ntfs. And what's really cool about our storage tiering implementation is that because all the storage concepts come right from Windows, we can, for instance, have an administrator override placement at the file level. So if I wanted, for instance, in a VDI deployment, I would have a VDI virtual desktop deployment. I would have a master VHDX file where a lot of my VMs are based on. And by putting that master VHDX file, forcing that thing onto the SSD tier, I can automatically, without having to have tiering move it, have all my VMs boot a lot faster because they're first reading from that file that's already in the SSD tier. So I can override the automatic data placement. And this is something that's really cool with our implementation because it's coming out of Windows. All right?
Okay, yeah.
Yeah. So with 2012 R2, another thing we did was we provided a capability for parity for dual parity spaces, where parity would provide resiliency to disk failures instead of just one disk failure. We also introduced a cool capability where I can, instead of having a hot spare lying around a JBOD being unutilized, we can rebuild any failed redundancy on my virtual disks to the spare pool capacity. To picture that, let's give I'm used to describing this with PowerPoint slides, so I have to think
Well,
of how
I
I
see you
want to
moving
describe here.
your hands around on the on the video.
Yeah, so this is a little different for me, but with parallel rebuild, what you would do is you would, instead of having a disk that you leave unutilized, you would take the same capacity of that disk that you would have left unutilized, utilize that disk, and just leave a little bit of capacity out in the storage pool, where we can go off, and if a disk fails, we can take all those, we can rebuild the redundancy to multiple drives simultaneously. And this brings us to, instead of having bottlenecked on a single disk throughput for rebuild, which might be like 100 megs a second, you can actually take multiple disks together and rebuild at 800 megs a second or potentially more. So we've had a test internally where we had 3 terabytes of data on a 4 terabyte disk. We failed that disk, and we were able to rebuild at 800 megabytes a second. Now, that is just incredible. That's way beyond what you can do with a single disk failure, right?
Yeah.
Yeah. So I know you
at
guys
some
wanted
point,
to get
the structure of RAID and the architecture of RAID and its failure levels became insufficient because the storage capacities were growing faster than the transfer rates.
Yeah, and the potential when a disk goes down of another failure increases dramatically as the amount of data increases, right?
Mm-hmm.
So it's very important to get a system rebuilt very quickly, and that's one of the reasons why we introduced that parallel rebuild. And of course, I don't want to have a disk lying around in my system being unutilized. That doesn't make any sense. Right? I want to get that additional disk performance, but I just leave the same disk's capacity lying around anyways. So it's the exact same amount of capacity lost. Right.
So what are you seeing in terms of reliability for the new flash storage? Because at least in my experience, when it fails, you get no warning. It's just gone.
Windows, we have something in the system called the Storage Reliability Counter, and it can pull data from these disks to show, for instance, temperature. I can see the number of errors, read and write errors reported. I can even see wear level. So, for instance, for SSDs, it would show as a percentage of the total wear.
Okay.
I have some SSDs in my very office that are at 100% wear because we've just been torturing these for the past year. So these SSDs are completely dead. So I know that by looking at these wear counters, these SSDs are unreliable to use. And in fact, they're so dead that just doing random writes to them, I only get like 25 megs a second out of an SSD. They're completely destroyed. All right, but these wear counters allow me to see these statistics. Right. So we talked about 2012 R2. We talked about the deployment scripts and building up a cluster. So now let's get to REFS, which you guys are eagerly anticipating. And a little background on REFS first is data is exploding. The amount of data that we have to manage is simply incredible. It's only going to grow exponentially. And while Ntfs is a great file system, it's rock solid file system. We use it for the past 20 years. We continue to improve it in every release. But of course, there are certain limitations that we start to run into with Ntfs. And one of those, the big things, is scale and the problems that come with scale. So for instance, you guys might have heard of probability of bit errors, occurring for individual drives, where a certain probability of bit error after a certain amount of data is written, is a certain number that comes with a hard drive. It's like typically 10 to the 14 or something like that. But 10 to the 14, seems a big number, but today it's really not that much, right? In a large data center, that might happen daily.
Sure.
Right.
Yeah.
Yeah. So REFS, one of the key pillars of REFS is data integrity. So we are able to detect bit flips or any inconsistency between written data on the disk and what we actually expect by putting what we call checksums on that data. And these are basically just CRC checksums that we put on the data to ensure that the checksum matches what data was written. And we can go back and we can read that data. We can read that checksum, and if it doesn't match, then we basically raise that this data is corrupt. And the reason why I want to talk about storage space before I talk about REFS is that REFS and storage space is one of those better together things. So remember when I talked about storage space that provides redundancy, provides resiliency, multiple data copies? The cool thing that also provides is the capability for applications to read those multiple data copies. A lot of RAID implementations can't do that. They don't have the APIs for that. And something like REFS can go figure out, okay, I just read copy 0. It looks like it's corrupt. Let's go read copy 1. It's also corrupt. I'm going to try copy 2. And if copy 2 is good, it'll return the data from copy 2 and automatically go fix the other 2 copies. And this is one of those things that only storage space can provide for REFS. Right? That ability to read from multiple copies and auto-correct data as necessary. REFS by default would put this checksum, this data integrity, on all its metadata and optionally put it on user data. Of course, there is a performance cost to this data integrity because as you write bits, you're going to need to find a new location for this data because REFS is not a update in place file system. We'll go and write data to a completely new spot on the disk. Because what happens with update and place file systems is that you can be exposed to issues which are called torn writes. So for instance, if I go and do a write, I have power interrupted in the middle of the write. I can get into a torn write situation where the write is partially completed. So to avoid that, we write to a completely new area of the disk. And because of that, there are some performance costs because we have to go update metadata in multiple locations. That metadata needs to find a new location on a disk. But we try and minimize this cost as much as possible. And that's something that we're working on right now for the next release of Windows. But for customers that really need this rock solid data integrity and need this guarantee, integrity streams is the only way to go. And that's what REFS provides. The other points that REFS provide is a very high scale. The REFS data structure scale to potentially petabyte-sized data sets. And we use Beach Plus trees for this. REFS doesn't have those issues of check disks that I talked about earlier because all these corrections happen online. All right. And if there was a unrecoverable error, so for instance, if I've gone through all the data copies, all the copies are corrupt, nothing I can do with this metadata. Instead of bringing the full file system offline potentially, we're able to excise a portion of that tree to keep the rest of the data online. All right. And one of the big things with REFS is that most of our future development, future innovation is going into REFS.
That's kind of where I wanted to figure out is this basically, should it be seen as the kind of the go forward file system? And at what point should we be using it first? And thinking about it will be, that's the default. Why aren't you using REFS? That kind of shift.
Yeah. So I'm sure some of the people that are listening to the podcast, been around for a very long time. They saw the shift from FAT32 to Ntfs occur in the Windows 2000 timeframe. And that was a gradual shift. We expect a similar shift to occur with REFS, whereby eventually maybe even the boot volume might even be REFS. But that's something that we're gradually working on. With Server 2016 coming out next year, we're making the default file system for server data volumes REFS. And that's one big step that we're taking to try and get REFS in the direction of being the default. But right now, we're making it the data volume only for 2016. Right.
Okay, cool. So are there downsides? Are there missing features that people will expect based on their experience with Ntfs today and in 2016?
So there are some missing features. Some of them missing as in great, it's gone. I don't have to worry about this anymore. And for instance, short names. There's no short name support in REFS. So for any developers out there that rely on short names, unfortunately, REFS is not for you. Go update your software. There are some other things like TXF that's not available in REFS. A TXF is a transactional Ntfs. It's something that we introduced. I actually don't remember when we introduced it, to provide transaction support, file transaction support in NTFS. It's not heavily used, so it's not a big deal, but it's not available in REFS. One big thing that might impact some application developers is there's no fast MFT enumeration in REFS because there is no MFT. That's something very NTFS specific. There's a few other
turn
limitations.
that into a use case. What does that mean?
So MFT is the master file table for NTFS, and some applications might use the MFT, like for instance, antivirus scanners or backup programs might use the MFT to have a quick way of scanning all the files on the volume, discovering all the files on the volume, and enumerating all their characteristics. There is no MFT in REFS, so there's no easy way for those developers to go. There's no quick way for those developers to go do that, so they need to find alternative means. Some other things like alternate data streams. We do have a limit on the size of the alternate data stream within REFS, and that's, I believe it's 128 kilobytes, with typically way more than anyone needs. But some application compatibility concerns. Basically, the way that we design REFS is that we took, we kept all the upper API layer stuff the same, so like Win32 stuff, FS controls, basically file system controls, and we swapped out the on-media data store. So NTFS has its data store that's MFT-based. REFS has its data store, and we call that data store the min store. But all the upper API layer, all the Win32 stuff, most of that stuff should just work with REFS, with the exception of a few things that don't work with REFS. And we have some resources online. If you just search for REFS at TechNet, you'll be able to find some of the stuff that REFS does not currently support. But of course, as we move forward to making REFS the default for more scenarios, we'd have to work on adding some more application compatibility as we see fit. And we have extensive AppCompat test labs within Microsoft to ensure that it would work with the majority of applications out there. But so far, I've actually not seen a lot of applications not work with REFS. I use REFS at home along with storage spaces to store all my photos. And I got a big JBOD upstairs that stores all my photos. I got 20 terabytes plus storage. And REFS, I've got no issues so far. Been rock solid. But of course,
does it support quotas? That was a specific question in the chat room.
So REFS doesn't support NTFS quotas, but there's other quota mechanisms built into Windows Server, which it does. So NTFS quotas, NTFS compression, NTFS encryption. These are very specific NTFS features because they're built into the file system. Those are not supported with REFS. Right.
So do you have replacements? Does the OS have direct replacements, or is it not the same thing when you want to achieve quotas?
It's a little different. It's a little different. So encryption would happen through BitLocker. Quotas would happen through the Windows Server. Windows Server has a quota mechanism, and you typically use the quotas for a file server, and that would happen through that way. Compression, there's no ability to do compression with REFS. There's no inbox utility to do compression with REFS. There's no file system support for compression currently. So that's one feature that's not available with REFS.
So what about, did you mention deduplication? Was that a feature?
Deduplication today only supports NTFS. We're investigating what it will take for it to support REFS, but that's not something that we have in plan for the next release right now.
Okay. When you say don't support it or you don't have it in plan for the next release, you're basically talking about 2016 release?
Yeah, we're investigating. Of course, dedupe is a feature that a lot of customers want and provides good capacity savings. But of course, there's other mechanisms to achieve capacity savings, like for instance, through parity spaces. So for instance, parity spaces can achieve at its highest capacity savings setting, 82% capacity savings, which is another way of getting...
Is that feature? What is that? I've never heard of parity spaces.
Parity spaces is you can sort of think of it analogous to how you would think of RAID 5, RAID 6. I'm a little reluctant to directly compare them to RAID 5, RAID 6, but it's probably the best comparison if you're most familiar with RAID groups. So basically, you would have a grouping of disks. You would stripe data across a number of disks, and then you would put parity bits in a few other disks. Instead of just doing direct mirroring, you would just have this way of storing the data in a more efficient manner. So for instance, with our most efficient parity scheme, I would have 14 data disks, and I would have 3 parity disks. And we call that 14 plus 3 parity. And that would give you 82% capacity efficiency. So out of 17 disks, I've had 14 for data and only used 3 for parity. Instead of, for instance, mirroring, if I had 3 disks, I would have to use, for 2 disk redundancy, I'd have to use 2 of those disks for redundancy and 1 of those disks for data. So that would be a 33% capacity efficiency there. So you can see how parity can deliver significantly more capacity efficiency than mirroring. With 2012 R2, our recommended deployment is to use mirrored spaces for Hyper-V workloads. But for archival workloads, parity would be very appropriate for that. Archival and DPM type of workloads. And the same goes for REFS. So REFS recommendation for 2012 R2 is basically archive workloads, and Ntfs would be recommendation for Hyper-V workloads. But that is changing in 2016, where REFS is the default for all types of workloads. Right.
Gotcha.
And you guys, you guys can go off and download the Server 2016 preview. The technical preview 3 got released a couple of weeks ago, and we would encourage you guys to try it out. We actually have a new version of REFS in that technical preview. We have quite a lot of under-the-cover improvements to REFS that did require a format change from the version of REFS that shipped prior to 2016, technical preview 3. But we definitely encourage you guys to try it out.
So are there any hardware requirements for using this file system or these new features?
So REFS doesn't itself have hardware requirements. We'd recommend REFS to be used on top of storage spaces for the ability for REFS to read from multiple data copies and do the auto correction. But storage spaces does have some requirements. For instance, I need to ensure that the JBODs I'm using are certified for storage spaces, and the Windows Server catalog provides a list of storage spaces certified JBODs and servers and all the other links in the chain that I would need to bring up a spaces deployment. With Server 2012 R2, we support SAS drives, dual port SAS drives. With Server 2016, we're moving towards a model where instead of having a number of JBODs which would be directly connected to a bunch of servers simultaneously, we're moving towards a model in 2016 where I can have a bunch of servers and just utilize those servers' local drives and have those servers clustered in a high-speed network. And I would use that high-speed network as a means to have my storage communicate, my storage nodes communicate to each other. That's what we call a non-shared model. With 2012 R2, shared model, all the servers see all the disks simultaneously through that shared SAS link. 2016, all the servers see all the disks that are in their own local servers through that high-speed Ethernet link. So that's a big change that we're making in 2016. And we expect, we expect that customers that have larger deployments up to a certain amount of scale to really like this 2016 shared nothing model, what we call storage spaces direct. But for customers deploying smaller deployments, maybe 2-node, 2 or 3-node deployments, the shared model would continue to be the way that we recommend, because the shared nothing model has a minimum node requirement of 4 nodes.
Okay, gotcha. So, are we at the point that you're that SQL admins are going to be using REFS or not yet? Directly. I understand the case for virtualization.
Yeah, so SQL databases, they actually they do support REFS. There are some considerations around, for instance, file streams, file tables, in terms of when you would enable data integrity or not, because SQL has its own data integrity mechanism built into it. But for the majority of SQL databases, we do support SQL on top of REFS.
Okay, cool. Yeah, I definitely wanted to understand that because that had some parallels to other software I'm familiar with at my day job.
I see.
Cool. Jonathan, any more questions for you?
No, I don't think so.
So, Brian, I wanted to, well, I'll give you a chance to finish. I think you were about to start a thought here, but I wanted to start to wrap up and give us some thoughts of where to go, calls to action, places to look for resources, that sort of thing.
Yeah, so basically the TechNet is a really great source of resources for store spaces, REFS, store spaces direct to look at some of the 2016 stuff. I would encourage you folks to do a search for spaces in TechNet, and you should be able to find a ton of resources for starting out a storage deployment. But I would really encourage you folks to look at the Spaces Automation Guide, because bringing up a storage deployment has its own complexities. There are some caveats. There are some best practices which can require some reading to get through, and the scripts trying to help you handhold you through every step of the process to ensure you guys have a deployment that's not only you made sure the disks are good, but you've also brought up the deployment following all our best practices, and then once that deployment's brought up, you actually performance tested to see what you got. And those sets of scripts are available again at aka.ms/spaces automation guide. It provides all the links to the script center where we have the scripts.
What about Channel 9 or Microsoft Virtual Academy? Is there stuff on there?
So Channel 9, I have a set of presentations that I've done at previous tech eds that talk about best practices, for instance, for deploying tiered spaces. And that's one I did at the 2014 North America Tech Ed down in, I believe it was Houston. And I talk a lot about some of the best practices, how to think about sizing. We also have sizing calculators that you can go off and figure out exactly what kind of deployments you need, what kind of scale you need, and you can give the outputs of the sizing calculator, basically the number of JBODs you need, the types of hard drives and SSD, number of hard drive and SSDs in those JBODs. You can work with OEM partners like, for instance, Dell or HP, which both support storage spaces today, and work with them to get hardware for spaces into your labs.
Excellent.
And the big thing about storage spaces is that we would recommend, instead of just taking off-the-shelf hardware that you'd build yourself from Newegg's or Fry or Amazon or whatnot, but to actually go to a certified hardware provider like Dell or HP or DataOn or Rating or whatnot, and have them build a fully certified and tested solution for you. Because we've seen a lot of inconsistencies around disk firmware versions, HBA firmwares, JBOD firmware, all sorts of different combinations that sometimes just don't work together very well. So having the OEM build a tested configuration is really the most optimal way to go.
So I've got one more question for you, Brian, before we let you go. This is the question that we ask everybody who comes on the podcast. If you could be a superhero or have a superpower, what would it be and why?
I think I'd want to fly, just to get a lot more accessibility. I mean, being limited to our bipedal motion is rather limiting, Just explore, hey, I want to explore that cliff top up there, I could just fly up there and go see it. I think that would be my superpower, want to fly. I don't know if that's a very common one, but that's what I choose.
It is. I don't have the stats in front of me. I need to need to do that. We need to have like a real-time visualization on this, Jonathan.
Yeah,
But
I
yeah,
wouldn't choose.
Superman flight, very popular.
I wouldn't choose.
We actually have them all written
invulnerability.
down, though.
Well, you can start a tally right now.
You wouldn't choose
have them all.
invulnerability?
I
Yeah.
wouldn't choose invulnerability because I think I'd get bored eventually.
Yeah.
After
and
maybe 1,000 years or whatnot.
Could you get your hair cut? I saw a post on Facebook. There was a picture of the new Supergirl, and somebody was
Yeah.
like, "How did she get her ears pierced? How's that work?"
Exactly. Maybe they're kryptonite earrings or something. Just go through. I don't know.
Yeah, I mean, simple things, like trimming your nails, become more complicated.
Yeah, exactly.
All right, well, Brian,
guys,
thanks a lot for giving us the time and extending all your knowledge. I mean, when we love talking to folks like yourselves with a lot of history and some of the concepts, really gives people a great sense of the context and the background. So appreciate your time.
Yeah, no
thank you
worries.
very much.
If you guys are open to another session when we ship 2016 or closer to ship, I'd be more than happy to stand in and talk about what we're done in 2016.
Yeah, that would be cool.
Awesome. Well, thanks a lot,
All right.
and we appreciate it, and have a good one.
Yeah, you too. Thanks so much. Have a good night.
Bye. All right, good show. So, Brian, if you're still on, we will let you know when this posts to the web, in case you wish to share it with others.
I dropped him already. Sorry.
Okay, well then,
He dropped.
never mind. Brian, never mind. I was just kidding. Cool. Yeah, I was not sure how that was going to work out, but was very pleased in the end. So.
Yeah, me too.
He worried me though at first. I don't know if you saw the email. He had sent along a basically a script.
Oh gosh.
It's like here's an outline of all the topics that I wish to discuss, kind of thing.
Oh boy. Well, that went a lot better than. I mean, we've had a few of those over the years, but this one has gone better than some of those.
Yeah.
For sure.
Okay. All right, somebody's calling my attention here. I'm gonna have to go ahead and let you go. I feel the need that we need to just like chat and just like kind of have like another kind of a wide ranging thing. Maybe we'll do that next week with Tomei. He'll be laid back. I think we'll have a chance to just kind of explore the space.
Yeah, that'd be good.
Cool. Well, you heard it, everybody. Next week, same time, Wednesdays is the new thing. And we're going to be having, we're going to be joined by Tomei
Tomasowski? I don't know how to say.
Tomasowski? I don't know how to pronounce it. Anyway, you know him. MVP for several years now. He's got something cool to talk about. So we'll see you guys then.
Good night, everybody.